All right, we're going to take another look at some sample problems for integration by parts. So in this situation here, we've got this integral x e to the x dx, and we're going to integrate this between 0 and 1. All right, so for this, let's go ahead and let's call u the x, and that means dx, which is the rest of the, or I'm sorry, dv, which is going to be the rest of this, is e to the x dx. All right, so now the derivative of x breaks down and just becomes 1 dx, and then the integral or antiderivative of dv is going to be e to the x. And so if we use our formula, and remember the formula for the integration by parts is going to be uv minus the integral of v u prime, and u times v is going to give us x times e to the x minus the integral of v, which is e to the x, u prime, which is du, so that's dx. Now the integral of e to the x, that works out easy enough. That is going to give us e to the x. And so that is our antiderivative that we are going to be now evaluating between 0 and 1. And we evaluate the whole thing. All right, so substituting in 1 is going to give you 1 times e to the first power, which is simply e, minus e to the first power, which again is e, minus, and then substituting 0 in will give you 0 times e to the 0, which will be 0, and then minus e to the 0, which is negative 1. All right, well, e minus e cancels, so then you have negative minus 1, which gives us a value of 1. All right, so now you're probably asking, well, how do I pick out what the u value is and what is the dv value or v prime value in all this? All right, well, there's a nice little acronym that we can use trying to figure out what the u value is, and the rest of it will be the dv or v prime. And that acronym is going to be LI8. All right, so LI8, this is your hierarchy of what you choose to be your u value in your problem. L stands for logarithms. I is going to be inverse trig. A is going to be algebra problems. For example, if you just have x or x squared or some polynomial. T is going to be trig problems. And E is going to be exponential. So if you have a logarithm and an e to the x, a natural log and an e to the x in your problem, then that means since L comes before e, the logarithm or the natural log is going to be your u value. All right, so let's take a look at this problem over here. We have two things. We have this function and we have this function, ln x, and we have x squared. Well, if you consider x squared is an algebra problem. So this is A. ln x, that's a logarithm. And so according to the hierarchy of Ly8, the logarithm comes first, therefore the logarithm is going to be your u value. So u, we will let be ln x, which means dv, or v prime, will be the rest of this. All right, so since ln x is the u value, that means that x squared dx will be the v prime. Now we fill in the rest of this little table here. If u is ln x, that means the derivative of that is going to be 1 over x dx. And if dv is x squared, that means v is going to be x cubed over 3. All right, so substituting everything into our formula, we have the formula being u times v, so that's going to give us x cubed over 3 ln x, that's the u times the v, minus the integral of v du. All right, so now we can simplify things just a bit here. On this, we can take the 1/3 out in front of the integral. That's going to be a coefficient here. X cubed over x would reduce down to just x squared dx. And now we can take the integral of this, fairly easy. And so we're going to have 1/3 times the integral, which would be x cubed over 3 plus our constant. And then, just simplifying a tad, would be x cubed over 9 plus c. And that is our antiderivative for this problem. All right, let's see if we can find the integral of this. This is a fairly common type of problem that we would like to know what the integral is, natural log. We know the antiderivative of 1 over x is natural log of x, but if we flip it around, and we've had this situation a couple times, what would be the integral of ln of x? Well, the integral of ln x is not 1 over x. That would be the derivative of ln x. So now we want to think about this in terms of integration by parts. It's a little bit tricky because we don't really look at this as a multiplication problem, but if we treat that acronym like we did in the previous problem, the L part of Ly8 is logarithms. All right, so we're going to let ln of x be the u value. Well, now what's left in our problem here is dx, which means that is going to be the dv, or the v prime. All right, so now let's plug into, well, let's go ahead and take the derivatives here. The derivative of ln of x is going to give us 1 over x dx. And then over here, the antiderivative of 1 dx is going to give us simply x. Now let's substitute into our formula. Our formula is u times v, so that will be x times ln x minus the integral of v du, or vu prime, which would be x times 1 over x dx. All right, so if we simplify this a tad here, x times 1 over x is just simply dx, and that means that this will give us x ln x minus the antiderivative of dx is just x, and then plus our constant on the end here. Alright, so the next example we have is going to be finding the integral of x times secant squared of x. And so if we identify our parts here, we have an algebra and we have a trig. Well, in the acronym LI8, algebra comes before trig. Therefore, the algebra part is going to be our u value. So the u value is going to be x, which means secant squared x dx is the v prime. And so the derivative of x is going to break down to be just 1 dx, and the antiderivative of secant squared is tangent of x. Alright, so using our formula, which is u times v, so that's x times tangent x minus the integral of v du, which is dx. All right. Now, the integral of tangent of x, we don't really have a formula for, but we can use a little trig identity to figure this out. Tangent is the same thing as saying sine of x over cosine of x. Now we can treat this as a u substitution problem. All right, so for u substitution, if I let my u value be cosine of x, that means du is negative sine x dx. All right, so let me rewrite the first part of this here. All right, so this would be separated as 1 over cosine x times sine x dx. That's just simply rewriting this right here. Now, in order for this to end up being du, I need to put a negative on that, which I can do. I can put a negative here as long as we put a negative out in front of our integral, which will simply change this to a plus. All right, so what that now gives us is the integral of 1 over u du. And the integral of 1 over u is natural log. And then we can replace natural log with what we said our u value is, and that is cosine x. And this is our antiderivative. Okay. All right. Again, we have a situation where we do not really see a multiplication, but we can still treat this as an integration by parts. And remember the acronym LI8. The I part of LI8 is for our inverse trig function. Well, that's what this is. So that means our u value is going to be tangent inverse. So we're going to have tangent inverse of x, which means dv is going to be dx. Completing our table over here, the antiderivative of dx is just x, and the derivative of tangent inverse of x is going to be 1 over 1 plus x squared. All right, so plugging into our formula, we have u times v, so that's x times tangent inverse of x minus v times, and there would be a dx on that, minus v times u prime. So that's going to be times 1 over 1 plus x squared dx. All right, so now let's look at this integral. So this integral, we can integrate this thing by using u substitution, where the denominator is going to be our u value. And so the u value is going to be 1 plus x squared, which means du is going to be 2x dx. All right, so we can rearrange a few things here, making this 1 over 1 plus x squared times x dx, which is just simply moving this x over here next to the dx. Now, in order for this to be du, I need to have a 2 with that x. So we can insert a 2 right here, which means we need to put a 1/2 out in front. All right, so that's going to give us x times tangent inverse of x minus 1/2 integral of 1 over u du, which we know the integral of 1 over u to be natural log of u, and we can replace natural log of u, making it natural log, and the u value is 1 plus x squared. Now, technically, we always put absolute value bars on the natural logs when we take the integrals. However, remember what absolute value bars do, and that just simply tells you that this is always going to be positive. Now look at your function. You have 1 plus x squared. When you square a number, that's always going to be a positive value. Adding 1 to that is always going to be a positive value. So putting absolute value bars around 1 plus x squared is not absolutely necessary. It is something I do, and it's just more out of habit than anything else, but it's not absolutely necessary because of what this function is right here.